Normandy, June 1944, 5 days after D-Day. British infantry clearing a heavily fortified German bunker complex near Caen. Concrete pillboxes connected by trenches, machine gun nests covering every approach, defenders who'd already repelled 3 Allied assaults with devastating casualties. Private Thomas Harker's unit had been pinned down for 2 hours, unable to advance across the 50 meters of open ground separating them from the German positions. Every attempt to rush forward met with withering machine gun fire. Artillery had barely scratched the reinforced concrete. Tank support couldn't navigate the crater terrain. Then Corporal James Reed stepped forward, wearing what looked like an absurdly large backpack. 2 metal cylinders strapped to his shoulders, connected by hoses to a metal wand he gripped with both hands. The contraption looked improvised, awkward, almost comical. Several soldiers had nicknamed similar devices the lifebow because the cylinders resembled life preservers. Reed didn't look heroic. He looked terrified, weighed down by 70 pounds of equipment, moving in short dashes toward the nearest bunker while his squad provided covering fire. Machine gun rounds kicked up dirt around him but miraculously missed. He reached a position 20 meters from the bunker's firing slit, close enough to smell the cordite from German guns, close enough to hear shouted German commands inside. He squeezed the trigger mechanism on his metal wand. A jet of liquid fire erupted from the nozzle, not a spray, but a coherent stream that arced through the air like a living thing, splashing against the bunker's concrete face and pouring through the firing slit. The flame burned at over 1,000 degrees Celsius, consuming oxygen, igniting everything it touched, turning the bunker's interior into a furnace. The German machine gun fell silent. Screams echoed from inside the fortification. Brief, horrible, then nothing. Black smoke poured from ventilation ports. The bunker that had held against artillery and infantry was neutralized in 10 seconds by one man with an ugly backpack. Reed moved to the next bunker, then the next, each burst of flame destroying positions that conventional weapons couldn't crack. Within 20 minutes, the German defensive line collapsed. Survivors surrendered rather than face the flame. The British infantry advanced, finally breaking through defenses that had cost them hundreds of casualties over 3 days. What Reed carried was officially designated the Flamethrower Portable No. 2, but everyone called it the Lifebuoy Flamethrower. It was ugly, heavy, dangerous to the operator, and absolutely devastating against fortified positions. The Germans feared it more than tanks, more than artillery, more than anything except perhaps fighter-bomber attacks. This is the story of the British backpack that turned ordinary soldiers into walking nightmares, and why flame became the ultimate weapon for breaking the unbreakable. Let's go back to World War I. The British Army first experimented with flamethrowers during trench warfare, recognizing that trenches and bunkers created tactical problems that conventional weapons couldn't solve. Machine guns, artillery, and rifles struggled against enemies protected by earth and concrete. But fire could reach into enclosed spaces, consuming oxygen, creating psychological terror, and forcing defenders to abandon positions or die. Early flamethrowers were crude, large, mechanically unreliable devices that required multiple operators and rarely worked as intended. The technology was primitive, the tactical doctrine undeveloped. By 1918, British flamethrower use had largely been abandoned in favor of tanks and improved artillery tactics. But World War II brought renewed interest. The defensive fortifications Germany constructed across occupied Europe, the Atlantic Wall, the Gothic Line in Italy, countless bunker complexes protecting strategic positions created the same tactical challenges trenches had presented decades earlier. British planners needed weapons that could neutralize fortified positions without requiring massive artillery preparation that announced attacks hours in advance. In 1940, the Ministry of Supply's Petroleum Warfare Department began developing modern flamethrowers. Their goal was creating a portable weapon that a single soldier could carry and operate, with sufficient range and fuel capacity to engage multiple targets, reliable enough for combat conditions, and safe enough that operators wouldn't become casualties from their own equipment malfunctions. The result was the Lifebuoy flamethrower, officially the Flamethrower Portable No. 2. The name Lifebuoy came from its distinctive appearance. Two cylindrical fuel tanks mounted on a carrying frame that resembled the famous Lifebuoy soap advertisement showing life preservers. The resemblance was purely coincidental, but the nickname stuck immediately. The Lifebuoy flamethrower represented sophisticated engineering disguised in utilitarian appearance. Creating a backpack-mounted weapon that could project burning liquid 20 to 30 meters required solving complex fluid dynamics, combustion chemistry, and safety engineering problems. The core system consisted of two cylindrical tanks mounted parallel to each other on a steel carrying frame. The larger tank held approximately 4 gallons of fuel, a special mixture of petroleum jelly, gasoline, and rubber compounds that created a sticky, napalm-like substance. This fuel mixture was critical because straight gasoline wouldn't maintain a coherent stream and burn too quickly. The jellied mixture held together during flight, stuck to whatever it hit, and burned intensely for extended periods. The smaller tank contained compressed nitrogen or carbon dioxide gas at approximately 300 psi. This pressurized gas provided the propulsion force, pushing fuel through the delivery system when the operator opened the valve. The gas pressure was carefully calculated. Too low and the fuel wouldn't reach adequate range, too high and the system could rupture catastrophically. The delivery system connected the tanks to a gun mechanism via reinforced rubber hoses. The gun consisted of a metal wand approximately 1 meter long with a pistol grip, trigger mechanism, and nozzle. The operator aimed the nozzle toward the target and squeezed the trigger, which opened valves allowing pressurized gas to force fuel through the system and out the nozzle at high velocity. The ignition system used a simple but effective method, a small pilot light burning continuously at the nozzle tip, fueled by a separate small gas cylinder. When fuel sprayed past this flame, it ignited immediately, creating the characteristic fire stream. Alternative ignition systems used battery-powered electrical sparks or pyrotechnic cartridges, but the pilot light proved most reliable in combat conditions. The complete system weighed approximately 64 pounds when fully fueled, a tremendous burden for infantry soldiers already carrying rifles, ammunition, grenades, and field equipment. The carrying frame distributed weight across shoulders and back, but operators still moved more slowly than unburdened soldiers and tired quickly under the load. Safety features were minimal by modern standards, but represented significant improvements over earlier designs. Pressure relief valves would vent gas if internal pressure exceeded safe limits. The fuel tank could be quickly jettisoned by releasing 2 buckles if the operator needed to abandon the equipment. Asbestos insulation protected the operator's back from heat radiating from the tanks during extended use. Operational capacity was limited. 4 gallons of fuel provided approximately 10 one-second bursts before depletion. This meant operators had to use their weapon judiciously, making each burst count, conserving fuel for multiple targets. Extended firing quickly depleted fuel reserves, forcing operators to withdraw and reload or switch to conventional weapons. The range varied based on conditions. Under ideal circumstances, calm wind, level terrain, fresh fuel mixture, the Lifebuoy could project flame 25 to 30 meters. Wind dramatically reduced effective range and accuracy. Rain didn't extinguish the burning fuel once ignited, but could affect ignition reliability. Cold weather increased fuel viscosity, reducing range and sometimes causing flow problems. Operating a Lifebuoy flamethrower required specialized training that went far beyond standard infantry weapons instruction. Soldiers selected for flamethrower training underwent intensive courses teaching technical operation, tactical employment, and psychological preparation for using what was arguably the war's most horrific weapon. Technical training covered equipment maintenance, fuel mixing procedures, pressure system operation, ignition troubleshooting, and emergency procedures. Trainees learned to identify potential malfunctions before they became catastrophic, checking for fuel leaks, monitoring pressure gauge readings, testing ignition systems, inspecting hoses for wear or damage. Tactical training emphasized the flamethrowers' role in combined arms operations. Flamethrower operators didn't fight alone. They operated as part of infantry sections that provided covering fire, suppressed enemy positions, and protected the vulnerable flamethrower operator during approaches. Training scenarios simulated bunker assaults, trench clearing, and urban combat, teaching operators when and how to deploy their weapons most effectively. The approach technique was critical. Flamethrower operators had to close within effective range, typically 15 to 20 meters, for reliable target engagement without being killed during the approach. This required using terrain for cover, timing movements between enemy fire bursts, and coordinating with supporting infantry who would suppress enemy positions during the final approach. Psychological preparation was perhaps the most challenging training component. Using a flamethrower meant burning people to death, not shooting them from a distance where you might not see the impact, but projecting fire directly into occupied spaces and hearing the screams of burning enemies. Some trainees couldn't overcome the psychological barrier and were reassigned to other duties. Those who completed training described it as accepting responsibility for inflicting the most terrible death imaginable. Operational doctrine emphasized specific target types. Flamethrowers excelled against bunkers, pillboxes, fortified buildings, trench systems, and any defensive position where defenders were protected by cover but couldn't escape fire entering their position. They were less effective against open field targets where defenders could disperse, and where the flamethrowers' limited range became a critical disadvantage. The British Army organized flamethrower operators into specialized assault sections, typically 1 or 2 flamethrowers per infantry company, supported by rifle squads tasked with protecting them. These sections trained extensively together, developing the coordination and mutual trust necessary for successful operations. The Lifebuoy flamethrower proved devastatingly effective in combat, particularly during the Normandy campaign and subsequent operations across Northwest Europe. Its impact went beyond physical destruction to include profound psychological effects on both sides. Against fortified positions, the flamethrower was unmatched. Bunkers that withstood artillery bombardment, positions immune to small arms fire, defensive works that channeled attackers into killing zones, all became vulnerable when flamethrower operators closed to engagement range. The fire penetrated firing slits, poured into ventilation openings, and filled enclosed spaces with flame and toxic gases. Defenders faced impossible choices: remain inside and burn, or evacuate and face small arms fire outside. The oxygen depletion effect amplified the weapon's lethality. Burning fuel consumed oxygen rapidly in enclosed spaces, creating suffocating conditions even for defenders the flames didn't directly touch. Many German soldiers found dead in flamethrower-attacked bunkers showed no burn injuries. They'd asphyxiated from oxygen deprivation before the flames reached them. The psychological impact on German defenders was extreme. Soldiers could accept the risk of bullets or shell fragments. Those were impersonal, relatively quick ways to die. But fire created visceral terror. The sight of flames streaming toward their position, the heat radiating through firing slits, the knowledge that fire would find every hiding place, this broke morale in ways conventional weapons couldn't. German soldiers who survived flamethrower attacks consistently described them as the most terrifying combat experience they endured. Post-war interviews with German veterans revealed that flamethrowers generated fear disproportionate to their actual casualty numbers. One veteran stated, "I faced Russian artillery barrages, American air attacks, British tank assaults. Nothing compared to the terror of seeing that stream of fire coming toward your position." German forces attempted various countermeasures. They constructed bunkers with multiple exits, allowing rapid evacuation when flamethrowers approached. They trained soldiers to shoot flamethrower operators preferentially, kill the flame trooper before he closes to engagement range. They positioned defensive positions beyond typical flamethrower range from likely approach routes, forcing operators to cross extended open ground where they were vulnerable. Some German units developed specific anti-flamethrower tactics, immediately suppressing flamethrower operators with concentrated fire, using mortars to target them during approaches, even requesting artillery fire on their own positions if flamethrower assault seemed imminent rather than face the flames. These desperate measures demonstrated the weapon's psychological dominance. The effectiveness came with significant cost to operators. Flamethrower soldiers suffered higher casualty rates than standard infantry. They carried distinctive equipment that made them priority targets. They had to approach very close to enemy positions to engage effectively. And they carried fuel and compressed gas that could catastrophically explode if hit by enemy fire. British flamethrower operators developed grim humor about their role. They referred to themselves as flame flingers or toasties, used black humor to cope with the horror they inflicted, and formed tight-knit communities bonded by shared experience of operating the war's most feared weapon. Casualty rates among these specialists were approximately 3 times higher than regular infantry, a testament to the danger they accepted. Despite effectiveness, the Lifebuoy flamethrower had significant limitations that prevented it from being a universal solution. The weapon's constraints shaped how and when it could be employed, and operational failure sometimes resulted in tragic consequences. The most obvious limitation was range. 20 to 30 meters under ideal conditions meant flamethrower operators had to close to nearly point-blank range by infantry combat standards. This required covering fire, favorable terrain, and often accepting casualties during the approach. Many flamethrower assaults failed because operators were killed before reaching effective range. Fuel capacity severely limited engagement duration. 10 one-second bursts might neutralize multiple bunkers if perfectly executed, but combat rarely proceeded perfectly. Operators sometimes exhausted fuel fighting fewer targets than planned, leaving subsequent objectives unengaged and requiring withdrawal to reload, a dangerous, time-consuming process rarely feasible during active combat. Weather dramatically affected performance. Wind could blow flame streams off target or reduce range unpredictably. Heavy rain affected ignition reliability. Extreme cold caused fuel flow problems. British operations in Northwest Europe during winter 1944-55 experienced significant flamethrower reliability issues attributable to weather conditions the weapons weren't designed to handle. The weapon's weight exhausted operators. 70 pounds of equipment plus the physical exertion of combat meant flamethrower soldiers tired quickly. Exhausted operators moved more slowly, aimed less accurately, and made tactical errors that increased vulnerability. Units learned to rotate flamethrower duties frequently, but this reduced experienced operator availability. Mechanical failures occurred with disturbing frequency. Hoses developed leaks, pressure systems failed, ignition mechanisms malfunctioned, valves stuck open or closed. A malfunctioning flamethrower left the operator carrying useless weight while defending with only a pistol or knife. Flamethrower soldiers rarely carried rifles due to weight constraints. The most catastrophic failures involved fuel tank ruptures or ignition while still attached to the operator. Several documented incidents occurred where enemy fire struck fuel tanks, causing explosions that killed the operator instantly and often injured nearby friendly soldiers. Other incidents involved premature ignition inside the delivery system, spraying burning fuel over the operator rather than the target. The moral complexity of flamethrowers troubled many participants. Using weapons that deliberately burned people to death crossed psychological lines even in total war. Some British soldiers refused flamethrower training or duty on ethical grounds, viewing the weapon as unnecessarily cruel. Others rationalized it as necessary for defeating an evil enemy who'd initiated the war. German propaganda seized on British flamethrower use, portraying it as evidence of Allied barbarism and war crimes. This propaganda ignored Germany's own extensive flamethrower use, but it resonated with some audiences who viewed fire as uniquely horrific compared to other weapons. The legality of flamethrowers under international law was ambiguous. While not explicitly prohibited, some argued they caused unnecessary suffering prohibited by Hague and Geneva Conventions. British military lawyers concluded flamethrowers were legal weapons when used against military targets, but acknowledged ethical concerns about the suffering they inflicted. Post-war psychological studies revealed elevated PTSD rates among flamethrower operators compared to other combat veterans. The intimate, horrific nature of killing with fire created lasting trauma. Many operators struggled with guilt, nightmares, and intrusive memories of burning enemy screams, psychological wounds that sometimes never healed. After 1945, flamethrower technology evolved significantly, though the basic principle, projecting burning liquid toward targets, remained constant. The lifeboat's design influenced post-war development worldwide, with military forces recognizing both the weapon's effectiveness and its limitations. The British Army continued using flamethrowers in post-war conflicts, including Korea and various colonial operations. The lifebuoy was gradually replaced by improved designs incorporating lessons learned during World War II. Lighter construction materials, more reliable ignition systems, increased fuel capacity, better safety features. American flamethrower development during and after World War II built on British innovations while incorporating distinctive features. U.S. forces used flamethrowers extensively in the Pacific Theater against Japanese fortifications, developing tactics and equipment specifically for jungle and island warfare. American designs generally emphasized longer range and greater fuel capacity compared to British versions. U.S. forces particularly for clearing vegetation and destroying tunnel complexes. However, the weapon's controversial nature, amplified by television coverage showing burning villages and napalm victims, contributed to growing anti-war sentiment. S forces replaced by explosive breaching charges and other bunker-defeating weapons. Soviet and later Russian forces developed flamethrower systems throughout the Cold War, creating increasingly sophisticated designs, including vehicle-mounted versions with dramatically increased range and fuel capacity. Russian military doctrine continued emphasizing flamethrowers for urban combat and fortification assaults long after Western forces had largely abandoned them. Modern military forces rarely use man-portable flamethrowers, having replaced them with thermobaric weapons, explosive devices that create pressure waves and intense heat without requiring liquid fuel projection. These weapons achieve similar effects against fortified positions while avoiding some of flamethrowers' limitations and controversies. The technological principle lives on in civilian applications. Agricultural flamethrowers for vegetation control, industrial devices for ice removal or surface preparation, specialized equipment for controlled burns. These descendants of military flamethrowers demonstrate the technology's versatility beyond warfare. International humanitarian law evolved to address flame weapons specifically. The 1980 Convention on Certain Conventional Weapons includes Protocol 3 restricting incendiary weapons, though with significant limitations and exceptions that allow continued military use under many circumstances. The protocol primarily aims to protect civilians from indiscriminate incendiary attacks, rather than prohibiting military-to-military use. The lifebuoy flamethrower was never elegant. It was heavy, mechanically crude, terrifying to use, and inflicted death in the most horrible form imaginable. By any aesthetic or moral standard, it was an ugly weapon, both in appearance and in what it did. But ugly doesn't mean ineffective. Against the fortified positions that defined much of World War II combat, the lifebuoy proved devastatingly effective. It solved tactical problems that conventional weapons couldn't, breaking defensive positions that had resisted everything else the British Army could deploy. The weapon's true power wasn't just physical, it was psychological. The sight of flames streaming toward your position, the knowledge that fire would find you regardless of cover, the understanding that death by burning was among the most terrible fates imaginable, this created terror that broke German morale and forced retreats or surrenders that bullets and shells couldn't achieve. For the soldiers who carried and operated lifebuoy flamethrowers, the experience left lasting marks. They accepted extraordinary danger, higher casualty rates, priority targeting by enemies, constant risk of catastrophic equipment failure. They inflicted horrible deaths and lived with psychological consequences that often lasted the rest of their lives. The moral questions surrounding flamethrowers remain unresolved. Was burning enemies to death morally different from killing them with bullets or explosives? Did the suffering flamethrowers caused exceed acceptable bounds even in total war? The answers depend on ethical frameworks that reasonable people continue debating. What's undeniable is that the ugly British backpack achieved its purpose. It turned individual soldiers into weapons capable of neutralizing fortified positions, breaking defensive lines, and creating battlefield conditions that favored Allied victory. The Lifebuoy flamethrower contributed meaningfully to defeating Nazi Germany, whatever moral complexity that victory carries. So why did this ugly British backpack turn into a flamethrowing nightmare? Because British engineers created a weapon that prioritized function over form, effectiveness over comfort, and tactical success over moral simplicity. They built something that looked absurd, operated dangerously, and killed horribly, but worked when nothing else could. The Lifebuoy flamethrower wasn't pretty. War never is. But it was effective. And in war, effectiveness matters more than aesthetics.
The Lifebuoy flamethrower wasn't pretty. War never is. But it was effective. And in war, effectiveness matters more than aesthetics. The German soldiers who faced it understood that truth more clearly than anyone. They learned that the ugliest weapon was sometimes the most deadly, and that the most nightmare-inducing backpack a British soldier could wear was the one carrying flame. From flame-throwing backpacks to garlic bombs to umbrella weapons, World War II weapons reveals the strangest and most effective innovations that changed warfare forever. Subscribe now for more incredible stories of weapons that won the war through ingenuity, terror, and sheer devastating power.